Hello, and welcome to another Cinemas tutorial. In this tutorial, we are going to learn how to obtain elastic constants, using Elastic Automatic module that uses VASP in Cinemas. This tutorial assumes two prerequisites. First, that you have already configured potential files parse. And the second, that at least one valid connection to a compute server is established. Separate tutorial videos can be referred for both of these prerequisites. Very well then. Let us start by creating a Cinemas project. You can give it any name you like, and save it at a disk location of your choice. And you can see that the project is created. Now, to start the automatic module Elastic, let us go to the right side of the toolbar and click the button Elastic. There are two modes: 1. Create an empty template, or second, start with a structure file. Empty template is nothing but a workflow where you can copy your calculation performed elsewhere, and use Cinemas only for post-processing. More efficiently, you can start with a structure file in a supported format, and perform the calculation, and obtain elastic constants automatically. Next, you can name your calculation. Here we are going to use silicon carbide as the test system. Let us give it a name, SiC elastic constants. You can check this box if you want to relax your structure first, else you're good to go as it is. Let us click OK. Cinemas will ask you to browse the structure file in a supported format. You can use structure in CIF, Pascal, XSF, and Espresso in formats. Right after you point to the structure file, Cinemas creates the workflow for computation of elastic constants. Cinemas displays settings for this module in default and user mode. Settings in default mode are optimized settings, however in the user mode, you can make more specific settings. Please note that settings cannot be changed in default mode, you have to switch to user mode to make specific settings. For the purpose of this tutorial, we will just accept the default settings. Immediately, calculation is prepared, and files are transferred to the compute server that was marked as default in the connections window. Now, files are being transferred one by one, and finally calculation will be submitted on the compute server. You will observe a delay of few seconds while submitting, as Cinemas is capturing the job ID. OK. So, now the job is submitted and you can see the icon on the workflow is changed. From the queue window, you can track the progress of the calculation. It shows the name of the calculation, the name of the connection, the job ID, and time on clock. From this window you can refresh the status, or kill it. You can use the clear button to clear this list, if populated. Alright, the job is completed, and the status if refreshed and icon is changes to completed. Status of the calculation can be observed from the workflow, as well as from the queue window. And output files are automatically downloaded to the local machine using Cinemas. Once the output files are downloaded, you can post-process it by clicking this percentage icon. Cinemas, with a single click, processes the outcar file and displays several elastic constants, as shown. The text can be copied and pasted elsewhere, if required. To conclude, in this tutorial we learned how in Cinemas, just by browsing a structure file, calculation for elastic constants can be prepared, performed, and processed to obtain several elastic constants. Thank you very much.